So today, I've been studying a lot of mechanical skills for my NSAA coming up because there's no calculators allowed. So I had found this A-level question, an integration question, 11 marks, and I think it's a very good demonstration of this kind of, oh, I just drew on myself, on this mechanical thinking skill, right? Like your integration thinking skill. It really helps you understand what to actually do, where to go, and how to deduce the best operation for any given function. So ln x, right? If you were given this integral, if you are anything like me, your first thought would be variable substitution. There's only one function of x here, so why use the product rule, or sorry, integration by parts? So that's what I did. I used u substitution, and if u is ln x, du is 1 over x, and therefore dx is x du. X, if u is ln x must be e to the u. That leaves us with the integral of u e to the u, which you would have to solve using integration by parts. So why not just skip that step entirely and go straight for integration by parts? So let's set our integratable term as 1 and our differentiable term as ln x. Writing out the formula, uv prime equals uv minus the integral of vu prime, we can deduce that this term is going to be the integral term, x times ln x minus. So I just made a ridiculous lapse in judgment, which reinforces to you, because this is important, that you should always double check your answer and always read the question, which again is not important here because I read the question, but it's very important elsewhere because I always misread the question. And I'm sure many other people do too. But also always check your answer, and if you think you made a stupid mistake, you probably did. So go back through it, because every time I think I made a stupid mistake, I did make a stupid mistake, and it can cost you entire questions, and it's cost me many questions. So yeah, I made a stupid mistake, and here I don't know what I did, but yeah, it's the integral of 1 over x times x is just the integral of 1. So integral of ln x minus the integral of 1 dx just simplifies to x ln x minus x plus c. I don't know why, but I thought the integral would be become the integral of just 1 over x on its own, because I times it by 1 and not by x, which I don't know why I did that, but it's always good to admit stupid mistakes. But yeah, I'm glad I caught that before I published the video. But yeah, so this kind of lateral thinking is what was kind of like a eureka moment for me. I'm like any other student, of course, and I struggle with integration a lot now, especially, but I struggled even more before, and this practice really drills it into you, and the more you do, the more you understand. And it often feels hopeless when you just write out integral after integral and you don't know what the hell you're going to do, but it really does work. After a while you start to get the hang of it, even if you really think you don't understand it, you do. So this next one you can do with integration by variable substitution, because, well, it's a function. It's just this was my first thought. I guess I always go for variable substitution as the first option. I don't know why. I like the name, probably because I just like the name, really. So if we let u equal ln x, and therefore du equals 1 over x, and therefore dx equals x du, and x equals e to the u. So writing out the formula again, we've got an integral from, well, I've got the uv prime equals uv minus vu prime, and writing this out, we've now got the integral of u squared e to the u du, which again we're going to have to use this for. Again, we're going to use integration by parts twice this time, which, don't let it scare you, just, you'll be fine. So this is going to be u times v. So well, first of all we need to set our differentiable term di. Our d term, we can make that u squared because that simplifies to just 2u, and e to the u remains e to the u. So this is going to be our integrated term, our normal, our left term, and times that by the integrated term, e to the u, minus the integral of 2u e to the u du. Now this, again, we're going to have to do it through the product rule again, or I keep saying the product rule, integration by parts. And so let's set our differentiable term and our integratable term. I bet you've seen this a lot, especially if you've seen the DI method where you go down. That method is good, but I prefer this one because it just makes more sense to me. And I think it would make more sense to a learning student as well, because it just makes more sense. There's no point cutting corners if you don't understand it. So that's 2 e to the u, because we're differentiating the term again, and leaves us with 2 this time. And therefore, this term is going to be, we're going to leave one term and give the integral of the other one. So that's 2u e to the u minus the integral of 2e to the u du. Now, this integral is just going to come out to 2e to the u anyway, because it's e after all. So this, if we put everything together, we've got now, we have u squared, I don't know if you can see this, u squared e to the u minus 2u e to the u minus 2e to the u. I guess you can kind of see a pattern here, is the left term is getting differentiated and differentiated again, and the e is obviously staying the same. That pattern is what you can use for the DI method. So undoing the substitution, we're left with ln x squared, e to the ln x is just x, minus 2 ln x, e to the ln x again is just x, put that in brackets, minus 2x plus c. And that's our integrand term. And again, this is exactly what we did here, but we have to repeat things and we have to manipulate things. And this is the exact type of thinking that I find very beneficial to myself when doing these questions, because it gets you thinking in that more lateral way and it makes you much more comfortable with these kind of questions, right? So yeah, so you've got your variable substitution, your integration by parts, and then your further integration by parts. So I think this question is very good. So that's 2 out of 3 done, and I think this was 5 marks, this was 3 marks. So that's 8 marks, and this one was, no, this was 2 marks, 5 marks, 2 marks, 7, because this one is 4 marks. So let's do this one. So this one may look much harder, but I think actually was a little bit easier than this one. I found it when I did it. Let's just get into it anyway. I'm going to do it in the middle because there's no point doing it here. Anyway, let's draw out the integral here. Ln of ln x over x dx. Now, straight off the bat, I'm going to start with integration by parts here because it's 2 functions of x. And again, you can see that logically. So I'm going to set my d term this time. I'll write it out here actually first. D term is going to be the ln of the ln x, and our I term is going to be the 1 over x that it's multiplied by. Because we know this integrates into ln x, we don't know what this differentiates into. We can use the chain rule for that. If you remember the formula, f prime of g of x times g prime of x. So f prime, that's the inside, or sorry, the outside function, that's 1 over ln x times by the derivative of the inside function 1 over x, which simplifies to 1 over x to the ln x. And next, well, using the integration by parts formula, again I'm going to write it out. uv prime equals uv minus vu prime. I think this gets messier the longer I do it. I don't know if this is going to work. Okay. Can you see this? You can see this. Okay. So, yeah, writing it out, we would have leaving the ln x, times it by the integral term. So that's ln of ln x times ln x minus the integral of 1 over x ln x times by ln x dx. Take a shot every time I say ln x. And now solving this integral, we have, if we just put everything together, ln x over x ln x, and if you recognize, then these two cancel out, and that leaves us with the integral of 1 over x dx, which again from the previous bit is just ln x. So this integral simplifies to ln of ln x minus, or sorry, times ln x minus ln x plus c. And that's our integral, the third integral, and the final 4 of the 11 marks. So 11 mark A-level integration question. I think this was 2012 paper 1 question 11, if I remember it. CIE, I think, Cambridge International Exams, I'm not sure. But yeah, I think this is a good type of question to do, and you can find more like this if you just search hard A-level questions. I think these are good questions because they're not artificially hard like some of the other ones. They test your ability rather than your pure manipulation ability, like your big fraction decomposition and things. I just like these anyway. But yeah, thank you for watching.